all of them have to bend the knee.
All of them.
And be grateful that Nuno did this work, because that math is now enabling the innovation for small form factor fusion nuclear reactors.
And exactly. You got it right. Nuno Loureiro. Yes. MIT professor, very unfortunate death.
Yeah.
And also the way that it happened through gun violence, like in his apartment in Boston. He really revolutionized our understanding of plasma physics. So before Nuno came along, there was something called the Sweet-Parker model. This was in the late 1950s. What ended up happening was, if you've got, a magnetic field going in one direction and a magnetic field going in the other direction, you've got this massive magnetic field gradient.
Yes.
And that reconnection of the magnetic field lines are going to crisscross, and they could actually calculate a time scale that would happen. So now we've got an observable. These Sweet-Parker sheets. What they're saying is, at something like the sun, I can see that happening.
Yes.
And so I can calculate how long it would take for that sheet to stay alive in some sense.
Mm-hmm.
Okay? Mm-hmm. And what they calculate is it should stay alive for a few months, maybe a few years. Okay. That is very wrong. It takes hours, minutes for a solar flare. Right. In tokamaks, it'll take milliseconds.
I was going to say, because if it's at a solar flare
scale, we've seen those things, right?
It's incredible, because that means anything we're doing locally on the planet Earth, like the tokamak system for like nuclear power production.
Yeah. Where we're trying to concentrate it into such a small volume,
means it's
going to be even faster.
The time scale's faster,
right?
So we're orders of magnitude off.
Yeah. It's not even a factor of 2. No, it's a factor of like 10 to the 6.
Right. The Sweet-Parker model is not correct.
Right? So this is where our hero Nuno Loureiro comes in. This is the paper that makes him famous. Okay. This is the one that has the most citations. It's got like 800 citations, which in plasma physics is like unreal.
Instability of current sheets and formation of plasmoid chains.
Yeah, this is he was at PPL at the time, Princeton Plasma Physics Lab.
Yes.
This is the one that puts him on the map of plasma physics, because he solves this 50-year-old problem.
Not bad.
Not bad, Nuno.
And the point is, you could not use this if you were trying to do fusion energy and you are focused on how do we contain the plasma.
Yeah.
You cannot use the Sweet-Parker model.
No.
And if
you'd be completely wrecked.
But for Nuno, you wouldn't necessarily have a framework for how to even do the math to do the containment of the plasma at that scale.
Exactly.
So when all these all these billionaires and hyperscalers and frontier model companies are saying we need more energy, and they're now investing in the small fusion reactor is like now a buzz term in